G'day, this is Shane from Shane's Computing Network and Cyber Security. I'm going to today I've decided to make another video to help those people in TAFE who are probably doing who probably doing network engineering or cyber security courses. So you're probably starting to become a network engineer or cyber security to fulfill a skills shortage in Australia. We're currently lacking in skilled professionals such as cyber securities and network engineers. So in today's video, I'm going to show you how to set up a lab environment with non-Cisco hardware. So in previous videos, I've demonstrated a lab environment using Cisco hardware with Cisco Packet Tracer. Today's video, however, I'm going to be demonstrating a lab environment using GNS3, which allows you to test and deploy configurations using network hardware from, say, Jupyter, WatchGuard, FortiGate, whatnot. Let's begin. I'll share my screen. Just a moment, so I set this up here. Audio. A few moments for it to actually display my screen. So what we got over here, as you can see, we got GNS3. GNS3, it's similar to Packet Tracer, Cisco Packet Tracer. It allows you to test and deploy networks. GNS3 is a little bit different, however. So with GNS3, I'm testing a Jupyter SRX firewall. I'll show you what that firewall is over here so you can see a picture of it. Pictures speak 1,000 words. 2 moments. All right, so yeah, here's the Jupyter. Here's Jupyter Networks. This is their network firewall. These are high-end firewalls, high-end devices. You see them in enterprise and corporate networks. Your websites and that you're probably visiting, probably running on a particular Jupyter firewall. Your social networking websites are probably running on a particular device like this. Corporate networks, so on and so on. So you'll see these devices or similar devices everywhere, typically in the comms cabinet in most business and organizations. Right, yeah. Now, the difference with GNS3 is it does require that you have a separate server to operate this on, but don't freak out. You can operate this server literally on your computer you're using now if you've got enough memory. What you're going to need is you're going to need something such as Hyper-V, VirtualBox, or VMware, which will works alongside with this. So you need 2 applications, your lab environment and a server to host your lab environment on. That's what I've got over here. I'm using Hyper-V and I'm running my lab environment, which is GNS3. So this is the server, which is running hosts the images of the network devices that you're downloading. And I'll tell you in a second where you get those images from. Right. So Hyper-V, I've signed this particular server about 600 megabytes worth of memory, about 4 virtual processors. I'm just using a laptop, which is about got 16 gigabytes worth of RAM. So that's as most as I can afford to assign. Those who have high-end computers can probably test more network devices. So yes, so with these images here, you pretty much have to go to the vendor's website and you got to search for evaluation copy images. With Jupyter, I had to sign up to Jupyter, and after a bit of browsing and whatnot, I was able to discover a evaluation copy to download these images. If you need assistance with that, just send me a message on YouTube, and I'll get in contact with you within time. I'm quite busy, but I'm always happy to help out the TAFE students. All right. So as I was saying, because these devices need a server to operate on, this is the server here, as you can see. That's your desktop environment. Ignore that. But what's that running on is, this is running on the GNS3, which is running the PC, the switch, and the Jupyter firewall. As you can see here, it's only using up to 58% of the RAM, 33% of the CPU. All right. Now to connect to the console of this, you'll pretty much just right click and you'll click console. I already got one open up here, preloaded. So this is a straight console connection to the actual device. I'll show you as well in this video how typically you'll connect physically to one of these environments using one of these console cables, which is a USB to RJ45 connection. Right here. Right. So what we use, us network engineers like to use cheat sheets, because when you're on the environment, doing the job, you want your commands all automized and handy. So let me bring up my cheat sheet. A few moments here. It's just a notepad. So there it is. All right. So regarding the cheat sheets, there's several ways you can get information from where these commands work. Most devices, you can just simply type in help or a question mark, and it'll give you a list of commands. You can go to the vendor's website, go through a lot of documentation. You can find commands that way, or if times of if you're looking for something more efficient, use the AI system. It can generate a lot of commands for you. The generative AI systems, they are good with that. However, whatever you do, never share your client's information with the third-party AI system. These AI systems are third parties. They're owned by different companies. They have different privacy acts and whatnot. So whatever you do, don't share your company's private network information with another company without their approval. That includes Gen AI systems. That includes posting the information on a blog or a web form. Don't do that. It's a major cybersecurity risk. Don't do that at all. Please don't do that. It's bad. You can jeopardize the security of your company. So yeah, you don't do that. So what I've got here is I just got some commands which I used with the assistance of generative AI. It generated these commands for me. I had comments say here, so this can basically explain the comments that you need. Now it's not as just simple as just booting up, a GPT program or whatnot, and just saying, oh yeah, help me connect to this network device. You actually got to know what technology you need to enable. For example, with this device, because I'm keeping it simple, I'm just enabling DHCP for now. But for network devices, you also probably need to configure static routes. Need to configure NAT. You need to configure network protocols which are allowed and not allowed. So you're blocking a port or you're allowing a port. You've got access control rules and lists and whatnot. It goes on, and that pretty much this command, which only enables DHCP over here, as you can see, which has only got 42 lines. When you're enabling more features, this is going to be hundreds of lines of commands. So no one's going to remember all that on the top of their head. That's why we use these cheat sheets. So anyway, what I'm going to do, I'm just going to give you a demonstration of this router. So what was it? COS. Oh, see, I typed in CLS, but it's not COS, it's actually CLI. Get into the root directory. Now I'm just going to show you, show system. So I'm going to show you the IP address assigned to this interface. I'm used to working with Cisco devices. They have different commands, but each vendor has a different command structure. You won't remember all of them. Keep your command sheets. If you're watching those Hollywood shows where you got a Hollywood show where you're watching those hackers and they're typing really fast into the keyboard, bashing the keyboard, that's make believe in Hollywood. It doesn't work like that way in the real world. 2 seconds. Oh yeah, that's not the one I'm looking for. I'm going to show the show interfaces. Typo. There we go. So yep, as you can see here, interface GE0-0, it's 0/0/0 .0. That's a VLAN, maybe. It's got an IP address of 192.168.10.1. This is this device here. Now I'm going to console into the PC. Right, I think I've already console cable into that. Actually, I already got one open up here. Stand by. All right, so this is the PC VPS. I'm just going to show IP. Leave it show IP. Right. I think I need to enable DHCP. Give it a minute. It's a bit slow because I don't have much SWAM. Yep, it's enabled DHCP, so show IP. Yep, it's got an IP address now. It's connecting to the gateway. which is the 192.168.10.1. So if I ping 2.168.1, I deserve a beer after this. As you can see here, it's pinging the interface, so it can see the network device. So yeah, this is just a basic setup. This firewall at the moment is just providing a DHCP to this computer, so I can connect to the local network. If there was another interface connected here, for example, like G01, that might go out to your outside internet, so they can connect to the internet. So yes, what I want to show you as well is this console cable, and pretty much if you're in when you're actually in the lab production environment, sorry, you want to get one of these console cables. This is a USB to RJ45 cable. And in order to work these cables, I'll show you how to work those cables. So what you're going to need to do is you're going to need to open up Device Drive Manager. Device Manager. Sorry, stand by. There it is. Audio. Give it a minute. Oh yeah. Right. Now then you're going to want to go down to ports and comms. This is just your typical Bluetooth links. Bluetooth being you probably use it for your mobile phone. So now what I'm going to do is I'm going to plug this cable into my computer, and it should come up with the COM port number. So stand by, because this is a really tricky part of the job. If anyone's used these USBs before, they know they can be a bit finicky. Plug this in. What's pain in a boy. Now, as an engineer, sometimes you might curse a little bit on the job. Most engineers do. Could be frustrating sometimes fixing things which are broken or trying to build new things, but you do get it in the end. But obviously I'm on YouTube, so I've got to try to watch my language. Anyway, so I plugged that in, and that's it. Give it a second. As you can see here, it's now showing up COM port 6. So then you plug this into the other end of into the actual device. But before you do that, you got to also make sure you install the driver for your device. So I'm just going to right click on the device, go to its properties. I can see the manufacturer is FTDI. They make chips, I believe. I believe they make chips. And basically, you need to go to the manufacturer's website, and you need to download the driver for this particular cable so it can work properly on your system. So when you have the driver and you plugged it in, you've got the COM port number. So you've got COM port 6. Let me just plug my mouse back in, because I've only got one USB on my computer. Just plug that back in. There we go. That away. Right. So now I'm going to go to PuTTY. Stand by. Then I'm going to go to serial, because this is a serial connection. And then I'm going to change that COM1 to COM6. You got the speed, the baud, uses 960 baud, 9060. You got your stop bits and your data bits. Typically you'll set flow control to off. That's the only setting you'll probably change. Sometimes the baud speed might be a little bit different. I believe baud is the speed of the bits per second. But let's not get too bogged down into technical details there. Typically, to find out this information, if you're working, say, a Jupiter router, or switch, or firewall device or whatnot, you look up, okay, what are the COM serial details for this? What baud speed you're going to use? What are the stop bits? What are baudity? So typically, they'll have it like this. They'll probably have it like 9600 N, which means no party or no flow control, and 1. So typically it might be written out like this. Now don't type this into the the box. I'm just going to give you a demonstration. Typically that represents the baud. 8 represents 8, N which represents none, and 1 that represents the 1. That's typically how they display it on the vendor's website. So I'm not connecting via PuTTY at the moment because I don't have a physical device to actually connect to. That's why I'm using using GSNet3 here. So GSN3, you go via the console. Rightio. So I believe that's I'll just keep the video a short video for now. So I pretty much demonstrated what you'll do in that. I'm setting up a lab environment for if you're working for other vendor infrastructure. Now, before you do any job, you always got to get a network topology diagram from the client. Client's got to have one. If they don't, then well, they best get one, or they probably need to hire someone to create one for them. Every organization and that has got to have a network topology. It's best to have this network topology on A4, like a big piece of paper, A3 piece of paper. That way you're not staring at a damn screen all the time. You can actually look at paper and it's better for your eyes. So you need a network topology. You're also gonna the client's gonna need to share their configuration information with you. So you're going to need to go into the actual network switch or the network router, and you need to print out the actual running configuration of that network device. So you can actually understand how the network works and also back that information up if things go wrong. That's very important. You need a backup copy of every network device that you configure. If the client is showing you network configuration information, you've got to keep that information confidential. You've got to keep it in an encrypted folder. If it's on a USB thumb drive, that drive's got to be encrypted with a password lock on it. You've got Windows encryption file service, for example. So say if you put in it in a file and save it in a file on your computer, that file's got to be encrypted. Yeah, no one can nick your information. I always use defense and defense. You've got your BitLocker to encrypt your hard drive. And also you've got your encrypted file server, which further encrypts it. So if someone comes in with a USB and tries to take the information off your computer, they won't be able to view it. So yeah, that's step number 2. Get that network topology information from the client, and make sure you encrypt it when you save it and back it up. Then step number 3 is you then duplicate the client's infrastructure in a lab environment to the best of your ability with the images and whatnot you can find on vendors' websites. So you'll need to go to a few vendor websites and see if you can get an evaluation copy of their network device, so you can put it into GSN3 and then you can test it. So yeah, step number 3, you build your lab environment. Step number 4, obviously, you test the new configurations in the lab environment to make sure that they will work, that you're not going to break anything. Then step 5, you kind of probably develop a document plan saying, okay, this is how we actually this is how we're going to deploy the configurations to your network. These are the results from the research into the lab environment testing. This has worked in the lab, so we have reasonably confident that we can now apply this into your production environment. Then the step after that, well, you deploy the configuration at a convenient time so it does not interrupt users. Typically, if you're just updating a network, they shouldn't see much interruption at all. Minutes. The internet might be down for 10 minutes. Not even that, probably. If you do your job right, it's only going to be down for a few minutes. The staff will probably love it. It's like, a few minutes where we don't have to work. Yeah, they'll love you for it. So yeah, they can go and have a coffee break. The staff while you update their network and whatnot. And talk by the water cooler or whatnot. It should be fine for them. Then after you deploy your configuration, well, there you're going to want to hang back for probably about an hour and make sure everything goes smoothly. Do some final initial testing to make sure that it's you have it, that the system's just not going to suddenly break on them the second you leave, because clients won't be happy with that. So yeah, basically to summarize that, get your network topology off the client, get the network configurations from your client, back up those network configurations. So in case if anything goes wrong, you've got a contingency plan and you can, return back to previous working conditions. Then test it in your lab environment, document everything, including your contingency plan, which is very important. Businesses love a contingency plan and risk assessment. and then deploy the configuration at a convenient time. If it's done right, the network should only be down for a few minutes. It's a coffee break for your staff, and then you hang back a little bit for about an hour just to make sure the network is everything is running smoothly. It's probably going to be an all-day job, maybe 2 days with the whole lab testing and documentation and whatnot. As an engineer, you're going to be charging Australian engineer rates, as an engineer would pretty much charge. Standard rate in Australia, because you don't want to undercut other network engineers in Australia. That's unfair to those engineers. Is you want to probably charge around $160 an hour. That's keeping things ethical, so you're not underquoting all other engineers, and that you are getting properly reimbursed for the time you are putting in for your technical skill, which you went through a lot of study to learn. So yeah, you're probably looking for about 1 or 2 days work, gets things done properly and correctly, everything documented. That way you don't have situations where you probably knock off critical infrastructure. Critical infrastructure is taken offline, or you've taken down some corporate environment and they're losing millions of dollars, or you've shut down some power plant. They got no electricity anymore, or the previous with that of a large Australian telco, they lost access. A firewall update, they lost access to emergency service. A few people died. So yes, there are safety concerns in this. You got to do the job properly. But that's why you get paid a decent amount. Well, that's why you deserve to get paid a decent amount for doing the job, because you do it properly. No worries. Anyway, if you're a TAFE student, send me some information. Just send me a message on YouTube or whatnot, and I'm a bit busy, but when I have time, I will respond to you, and I'll help you with your studies and give you some advice if you need it. Right, yeah. All right. Well, I think I deserve a beer now, because I've done my public service. I'm helping out helping out the aspiring students. Helping to help a skill shortage. Yeah, that's right. Helping the Australian skill shortage the best way I can. So we stay a secure nation and providing free education. So that means I'm allowed to, I deserve a beer. Anyway, you have a